Hey guys, so this month we're going to look at changing articulations in our HISE instruments. So for example, if you have an instrument that has, let's say, a sustain articulation and a staccato articulation, we're going to look at how you can have both of those loaded and switch between them. So I've made a new folder on the desktop. It's just called November. So in there I don't have anything other than some samples, and these are just some clarinet samples. And we've got 3 articulations: sustain, staccato and flutter, and these are what we're going to be working with today. So if I open HISE, let's begin. So we're going to need to add a sampler, and we're going to start mapping these samples. Changing articulations starts with deciding how you're going to map your samples, or how you're going to organize your samples and the articulations. Now, if you're coming from other samplers, the most obvious way is to put the samples into different groups. So let's start with that. Right, so by default we're in group 1, and we've only got one group. This RR groups here is where we set the number of groups. So I'm going to change it to 3 groups. Now it's called RR groups because by default these are triggered in a round robin pattern, but we're going to change that. Okay, so I'm going to load the sustains into the first group. To get into the mapping view, I'm going to click this little button here, which will take us to the mapping view. You can also get there by clicking this button here as well. So we're still on group 1. This is just like a blown up view of what we had on the other screen. And we could actually drag these from over here. So if we go to samples and sustain, and we select all the sustain samples, and we can drag those on, and we'll use the auto mapper to place them. I don't have to worry about that. So the only thing I'm interested in is the pitch. These are all just, we're just using one dynamic and one mic position and one round robin. So the only thing I'm interested in is mapping the pitch. And that's set up correctly, so I'm just going to hit OK. And so that's mapped them to group 1. Now actually that's just, I clicked the button there too quickly and I've just set it back to 1 group. So I'll just change that back to 3. So we're back to 3 groups there. So now we're going to map the staccatos to group 2. So we'll switch to group 2. And we'll drag these in, and we'll do the same with this. Yeah, that's fine. Now, although I've got group 2 selected down here, it's actually mapped those samples to group 1. So what we have down here is just the display group, but by default the samples are put into group 1. And now the problem is the sustains and the staccatos are both in group 1, and it's kind of difficult to select them in the mapping editor. So I'm actually going to go over here to the table view, and this makes it really easy. I just scroll down, and there's the first staccato one there, and all of these are staccato, so I can just hold shift, and now I've selected all the staccatos, and now I can move them to group 2 by changing the RR group. So I'll just change that to 2, and now if we go to group 1, we've got the sustains, and if I go to group 2, we've got the staccato. So we're going to do the same thing, but this time for the flutter, and there's actually less flutter samples. These start on these have a different range to the other 2 articulations, but that's not a problem. We can mix the number of samples for each articulation. And I'll just do the same thing. Find all the flutter samples and move them to group 3. There we go. So that's all of them. That's group 1, that's group 2, and that's group 3. The next thing is to save this sample map. So I'm going to hit save here, and I'll call this all articulations. So the way that RR groups work by default in HISE is it works in a round robin cycle. So if I play a key, it's going to trigger group 1, then if I press the key again, it'll trigger group 2, and then if I press the key again, it'll trigger group 3, and then once more it'll go back around to group 1. And we'll actually see which round robin group it's triggering by the number here. So it says group 3 for the group we've got selected, so I've changed that to all groups now. But this little number next to it, this will show the actual group that's triggered. So if I press a key, it's going to trigger group 1, and then that number will change to 2. There's a bit of a delay on some of those, and that's just because the samples don't actually start at the beginning. Okay, so yeah, this is triggering now in a round robin cycle, and this is not what we want. We want one articulation at a time. So when you write your script to change articulations, you can write it as a script for the individual sampler. That sometimes is a good idea if the articulations are only relative to one sampler. You can write it as an overall script that covers the main container, or you can actually include it in your interface script. Now, which one you choose will depend on what you're doing. Where possible, I recommend you don't put it in your interface script and you have it as a separate script. That way it's more modular, and if you want to take it and reuse it in another project at a later date, then it's easier just to take that one module. But there are occasions when it's better to include it in the interface script. For example, if you have things on the interface that need to update or change when the articulation is changed, then it might be a good idea to include it in the interface script. So for example, if the user changes to staccato and you want it to say staccato on the interface, then that's a good candidate for having it inside the interface script. But we'll just write it as a separate script. We don't even have an interface script yet. Let's add an interface script first. And now we're going to write, I'm going to add a separate script, and we're going to call this articulation changer or something like that. Let's call this group articulations. Yeah, that'll do, because this is going to be group based. Now, one limitation we're going to hit straight away with this. So in HISE, if you're going to use groups like this and you're going to have each group for a different articulation, you can only enable one group at a time. So if you need to have 2 or 3 groups for one articulation, this method isn't going to work very well. And if you're going to have like multiple dynamics layered into the different groups, again, this isn't going to be the method you can use because you can only have one group enabled at a time. Now, when you're using groups for crossfading and you enable the crossfade thing here, then you can have multiple groups enabled at a time, but you can't use this technique for switching articulations. So it's one or the other. It's either you're using the groups for dynamic crossfading or something else that requires all of the groups to be active at once, or you're enabling a single group at a time. Okay, so let's go into the script editor. So we're sort of jumping ahead a little bit here because, as I said at the very beginning, there are 2 parts to this whole articulation changing. There's the organization and there's the changing of the articulations. And we've done one method of organization, which is groups. But in order to fully demonstrate how we're going to use them, we're going to have to go into the actual articulation changing. So we're going to start with something simple just for this one. We're going to have key switches. So we're going to have 3 key switches to change between the 3 articulations. And I'm just going to define the key switches in an array. So those are our 3 key switches, key 24, key 25 and key 26, and we can colour those on the keyboard very quickly. We'll just do this in a loop. So do an engine.setKeyColor, and we're looping through the key switch array here. And this should be all pretty standard stuff. And that's the key number we want. It's the key switch and then the index. And then the key color, there's a built-in constant for colors. So if I do this, so colors, I'm going to choose colors with alpha so we can have some transparency. And we'll have colors.red. And for the transparency, we'll have 0.3. And if I press F5, hopefully our keyboard colors will update. There we go. So now we've got our 3 key switches. So that's a really quick way just to color a few keys on the keyboard, but they're not actually doing anything yet. We've just changed the color of them. Now the next thing to do is to tell the sampler that we're going to take care of the round robin groups and we're going to manually turn them on and off. So this is a per sampler thing. So if you're dealing with more samplers, you might need to do this in a loop, or you'll need to put a script for each sampler. But we're going to get a reference to the sampler. So I've just right clicked on it and create generic script reference. And if we go back into the code editor, I'm just going to paste this reference in. And we're going to tell it that we're handling the round robins. And the function for that is is somewhere in here. There it is, enable round robin. And we're going to set that to false. And if I hit F5, what's that? Function not found. Oh, okay. The reason it's saying function not found is because I've grabbed the reference to the sampler as a child synth. I should have grabbed it as a sampler. So we can get around that manually, but I'll just show you how to do it when you first grab the reference. So when you right click, instead of selecting create generic script reference, select create typed sampler script reference. And then we paste that in. Okay, and now I'm going to hit F5 and hopefully we won't get any errors. Brilliant. Okay, so now let's have a look at what happens when I press a key now. So before it was triggering the groups in that round robin fashion, and let's just close that sample editor, we don't need to see that. And now if I press a key, it's only triggering the first group. So now that we've disabled the round robin handling, it's now triggering just the first group every time. So now we can control in the onNote callback which group is triggered. And we're going to do this based on the key switch. So let's go to the onNote callback. So I've opened this in a separate tab. You can see I've got multiple tabs here. So we've got on init in the first tab and onNote now in the second tab. Right, so what we need to do is check if a key switch was pressed. So we're going to, let's see, we'll have an if statement, and we're going to check if the incoming the incoming note number is in our KS array. And we're not going to write out is it 24 and then say is it 25 and then is it 26. We're not going to do each one. We're going to do it really quick. So we're just going to do ks.indexOf. It's one of my favorite functions, .indexOf. And we're going to say message.get note number does not equal -1. So I've explained about what the indexOf function does, but basically it looks in the array that it's attached to for the value that you're passing in, and if it doesn't find it, it returns -1. If it does find it, it returns the index of the value. So if it found 24, it would return 0. If the note was 25, it would return 1, and if the note was 26, it would return 2. But all we're interested in is it any of those? And we check that by saying, is it not -1? So if we got to this stage, it means it is a key switch. So now we have to enable the correct round robin group. And we use, let's type in here, we use the group command. So you can see it's also assigned to the sampler. And the command is set active group. And what's very important in here is it says enables the group with the given index 1 based. So it doesn't start from 0, it starts from 1. So we put the name of our sampler and we can go set active group. And then we need to give it the group number, and we can get that from the indexOf function. So we can just copy this and paste it down there. But we've got to add 1 to it because the indexOf function is 0 based, whereas this function, as we've discussed, is 1 based. Okay, I'm going to hit F5 and hopefully this has worked. So far so good. We didn't get any errors. So now I'm going to play a key, and it should still be in group 1, so we should just hear the first articulation. And now I'm going to hit our second key switch, which will be C#0 there. And now when I play it, should now trigger the next group. We can actually see here the group number has changed to 2. Oh, we need a bit more on the ADSR release there, don't we? Let's bump that up a bit. That's a bit nicer. And now if I press D0, we should see this number change to 3. There we go. And if I press C0, it goes back to group 1. So that's really basic articulation changing using groups. Okay, now let's look at another technique. I'm actually going to leave this one here. I'm going to call this group based. I'm going to turn this sampler off. We're not going to use this sampler for the moment, but I'll leave it there. And I'll turn that off as well. We still get our key switches coloured, but we don't have to worry about that. So the next method of changing articulations is one I do use quite a bit, and it's velocity based, and there are different ways to implement this. So I'll add another sampler, call it velocity based, and we'll go into the mapping view for this. So I'm going to drag the sustain samples in again, and this is just the same as before basically. And these, let's say we want these to go to velocity 70, so I've just changed that down here. And now we'll have the staccatos. And we'll just map those. And we'll have these start at velocity 71. So if I play velocity below 70, we're going to get the sustain samples. And if I play above 70, we're going to get the staccatos. Again, you've got the problem that you can't have different ADSRs and other modules applied to just individual velocity ranges without additional scripting. So I do use this one quite a bit. I usually put them in separate samplers so that I can actually overlay samples on top of each other. So I'll do the same thing, but with a bit of scripting to decide on the actual velocity trigger point, and I'll have both samples trigger at the same time. You can do this in a single sampler just by overlaying them, so let me show you that. If we increase the sustain samples there, so they actually overlap the range of the staccatos. Now if I play within this middle range, it's going to trigger both samples at once. So that's quite a useful technique if you want to do overlaying. If you want more control over that, then I'd say put them in two separate samplers and do the overlay through scripting. Now another variation on using velocity to organize your samples is, well, let me show you. Let's say instead of having them cover a massive range like this, let's just have the sustains go from 0 to 1, and the staccatos can go from 2 to 3. And we'll bring in the flutters. And the flutters can go from 4 to 5. And again, I'm going to save the sample map. So now we've got pretty much the same thing we had before with groups, but now we're separating them over a velocity range instead. Now the real advantage of this is we have 0 to 127 velocity values, so we can fit 127 articulations in, separated by velocity, and it only uses one sampler and one group, so you could also use the other groups for other things as well perhaps. So let's have a look at how we change with these. So it's going to be very similar to our group based, but I'm just going to put this actually inside this one sampler. We'll call it velocity based. Now we don't need a reference to the sampler because we're not going to do anything with the round robin groups. And we don't need to colour the keys because we've already done that, but obviously if we didn't have that script that was colouring the keys, then we need to colour the keys as well. We will need our key switch array. Again, we're going to use key switches to do the switching here just because I'm demonstrating the organisation of the samples, and we'll get into the actual methods of articulation switching in a little while. So we'll have a key switch array, same keys. Okay, now this is going to work in a similar way to what we had previously with the groups, but because we don't have the group number to track which is the active articulation, we're going to need our own variable to do that. So I'm going to make a reg variable. I'll call it C for current articulation. You can give it a longer name if you want. We'll default it to 0. We're going to need that if statement we had before to check if it's actually a key switch. So I'll just copy that and paste that in here. And then we don't have the group variable to set, so we're going to set our custom variable for tracking the current articulation, so that's C, and we're going to set it to the index of the key switch times 2. So we're not going to add 1 to it, we're going to times it by 2, and the reason we're times it by 2 is each of our articulations covers 2 velocity values. So we've got 0 to 1, 2 to 3, and 4 to 5. So we have to multiply by 2. And then the next thing is when we play a note that isn't a key switch, we have to actually set the velocity of that note. So what we'll put here is else. So if it isn't a key switch, we're going to change the velocity. So set velocity, and we'll just set it to C. And that should work. So we should be on the first articulation. And now if I press C sharp 0, we're now on the second articulation. And if I press D0, we should get the flutter articulation. Now, as with the when we did it group-based, we lost something in what we could do with the groups. We kind of lose something here with the velocity-based, because now we can't use velocity for things like envelopes. We're obviously already using the velocity in the mapping editor for samples, so you can't use it to change dynamic, but we can't use it to change the envelope or any other modulators. And let me show you what I mean. So if I was to, let's say we want to modulate the attack time based on velocity. So I'll add a velocity mod here, and we'll put the table on so we can see what's coming through. So if I play, let's put it to flutter tongue. So we're on the flutter tongue articulation, and we can see, you see that line that appears in there, that shows the velocity I'm playing the note at. Now I'm playing key switches, so they're not going through that set velocity function. So key switches are fine, but as soon as I play a note, so I've selected the flutter tongue, as soon as I play a note, just watch this line. Drops down to there, and now I'm going to play this key really hard, and still the velocity stays where it is. If I change to the next articulation, the staccato, you see it goes down a little further. If I change to the sustain, we're right at the beginning because the sustain is 0. So we lose this velocity modulator control, and I don't like that too much because I like using the velocity modulator. So there is a solution to that. It's kind of an aside to what we're actually doing here, but you'll find it useful, I think. So we're going to use a global modulator, and we're going to use it before anything hits our script. So I'm going to right click on this and say add processor before, and put global modulator container. So this is before our sampler and it's before our script. It's not before this script. It's not before this script, but this one isn't affecting velocity, so that's fine. And we're going to add a global modulator, and it's going to be a velocity modulator. So we'll have the table in there. Now I'm going to play some notes, and you'll see that the velocity actually affects this one as it should. It's not restricted. So we need to just link to it down here. So instead of using its own velocity modulator, we're going to add a global voice start modulator, and then select our velocity modulator here. I'll put the table on, and now this should work just fine. So that way we don't lose access to our velocity modulators, which are really useful, and we can still use velocity to separate out our articulations. Okay, I hope that little extra tip there will come in handy for you guys. I use it a lot because I like to control attack time with velocity, so this particular little trick is something I do use. Okay, another way of organizing the samples. I'm not actually going to do a full demonstration of this because it's pretty much the same as we've done for velocity, and I'm sure you'll be able to work out the rest of it, but we'll add a sampler. The other way that I'm going to show you is to spread them out across the key range. So let's map some more samples. So we'll start with the sustains again. So we've got the sustains there, right where they should be. Now these start on this D, and they go all the way up there. Now let's map the staccatos. Actually, what I'm going to do, just to make my life easier, is I'm just going to bring these down on the velocity range. We're going to put them back up eventually. It's just so I don't have to keep scrolling up and down in the table view. I'm just going to do the same thing with those as well for now. And then we'll map the flutters. Okay, so instead of having our samples covering the actual playable range that they play, we can move them around and then just transpose the notes as they come in. So let's move these down. So we could do something like that. Move the high key as well. And we've got to move the root note down as well. So there we go. So that's now the flutter tongues now have their own range on the keyboard. I think they're actually covering our key switch range, but this is not really an issue because I'm just demonstrating. Let's see, that would go up there. Now we might hit a problem here because we might run out of keys. Let's have a look. Yeah, so the sustains we can see need to actually be moved down a bit. So what I'm going to do is just raise these staccatos up just enough so that I can select the sustains and the flutters, and we're going to move them all down a bit. Okay, and then the next thing to do, of course, is just to make sure they cover the full velocity range. Okay, so now we've got the 3 sets of samples mapped across the keyboard rather than the velocity range, and I'll leave this up to you, but basically you just need to do the same thing that we did with the other 2 demonstrations in as far as determining which key was pressed and then just transposing the incoming notes to make sure they're in the correct range for the selected articulation. So another thing, while I've got them like this just mapped across the keyboard, you don't have to have articulations changed so that only one articulation is triggered at a time. With some of my instruments, and I've seen other people do this, it's actually useful just to have all of the articulations spread out in this exact way we've got, so that the user has access to any articulation they want without having to change articulation, as it were. So we've got the flutters down here, the sustains, and then the staccato. And that doesn't require any key switching to change between articulations, so that can be quite a good technique. I wouldn't recommend it with a clarinet though, because it will go beyond the actual range of an 88 note keyboard. That's my lowest note on my 88 keyboard, and my highest. And that doesn't cover the range of these articulations, and that's only 3 articulations. So maybe not the best thing for a clarinet, let's say, but I've used it with other instruments where I'll have the main sustain articulation mapped in one region of the keyboard, and then I'll have maybe some ornaments and trills and things mapped to another range, and that can work out really well. So don't always think that switching articulation means you just have to have one set of samples available at a time. You can still have multiple sets available at once. Okay, and there's sort of 2 last ways that I can think of, at least, to organise the samples. You may come up with some other ideas as well. Don't think that I'm just telling you everything that's possible. There may be other ways. So I'm going to just delete this one for now. So one common technique I've used in HISE, and I think a lot of you will end up using, is to have different articulations in different samplers. And this can work really well if you need to apply different scripting or different modulators to specific sets of samples. It can also work out really well if you want to layer samples, but again have different parameters assigned perhaps, or you just don't want to have to deal with more complicated scripting. So this can be a really good technique for that. So I would have 2 samplers, let's say, for sustain and staccato. So I'd call this one sustain, and this one staccato, and let's map some samples again. Okay, so I've mapped the sustain articulations to the sustain sampler. I'm going to switch to the staccato sampler now. And I mapped the staccato articulation samples to the staccato sampler. The best method I've found for this is to have your script outside of the samplers. So rather than putting it inside the samplers, you'd have it in a container on the outside, and usually I put the samplers inside their own container, but I haven't done that this time. So we're just going to have a script added up here. Now what we need to do is we need to turn off the sampler that isn't being used. So this is kind of like how we'd do it back in Contact, for example. except we'd do it with groups in contact, where we'd turn off all the groups that aren't being used and just turn on the groups that are. Now, we don't want to toggle these bypass buttons, because that will create, when we do that, it doesn't just bypass the MIDI from the sampler, it also does some other things in the background, and it would cause audio artifacts, which we don't want. We just want to stop the MIDI coming in, and we can do that using MIDI muters. So if we add a MIDI muter to each of these samplers, where is it? MIDI muter, there it is. And I always select fix stuck notes, and that will stop hanging notes. Most of the time you'll want that on. There are some occasions when you may not. And again, a MIDI muter and fix stuck notes. And I'll usually give these names: sustain muter, staccato muter. That's perfectly valid. Another option is to actually just give them numbers at the end if you want to grab them in a programmatic way and loop through them. So there's different ways to deal with that, but this will do for ours. I'll just give that a name, sampler articulations. So I haven't added the flutter tongues to a sampler yet. We'll look at that later, but let's just go with our sustain and our staccato. So we're going to have two key switches this time. So why did I put that in quotes? 24 and 25. And what we need to do is get those two muters. So we'll just create a generic script reference to the muters, and we're going to store these in an array. So that'll be sustain and staccato, and we're going to have these in an array called muters. So muters 0 is going to be our sustain one, and muters 1 will be our staccato muter. So what we can do now is we can control which one of these is on based on the key switch. So let's go to our script. We're going to need that same if statement, so I'm just going to grab it from our previous script and paste that right in there. There are a couple of ways we can do this, and the first and sort of most obvious way is we have a loop. So we go for I equals 0, I is less than the key switch's length, I plus plus. And we could do that, and we could just turn off the muters. So muters.set attribute, actually it's muters with the I there, dot set attribute, and the attribute would be 0. It's probably got a proper, let's have a look, what would it be? MIDI muter. So it's not the bypass button, so it's not 0. It is semitone slider pack. This is not in order. Okay, so it's actually, these are out of order, so the muters is set for the channel setter, so it actually be, so it would be 0, so it's ignore button is the constant we're looking for. So it would be muters I dot ignore button. I'll set that to 1. So now if a key switch is pressed, it's going to bypass both muters. So watch these ignore events buttons, ignore all events buttons. So it doesn't matter which key switch I'm pressing at this stage, it's just bypassing them all. And if we get rid of these bodies, we can just have a look. There we go. And now we need to enable the correct muter for the key switch. So we just go muters, and then we can select this index of thingy. And then again, we're just going to do this set attribute. I'm just copying and pasting because I'm being lazy. And we'll set that to 0. And it doesn't matter which one we put in there, so we'll just put that as 0 instead of I. There we go. Semicolon on the end. I'll hit compile. Okay, we've got an error here. Expecting semicolon on line 9. Didn't I put a semicolon? I put a semicolon. Oh, need to put a dot. There we go. Okay, now if we watch the muters, I'm going to press C0, and now the first one is unmuted, and then I'm going to press C#0, and now the second one is unmuted. So now only one is active at a time. Now this brings into play some inefficiencies. So we now have a loop inside the onNote callback, and this is bad because the onNote callback is a real-time callback, and if we're having loops inside there, that's going to cause the program to basically have a delay, and that could cause some nasty audio artifacts, especially if it was a bigger loop. So we really don't want to do that, and there are two solutions to this. So the loop is nice and easy, especially if you've got a lot of articulations. So I'm going to show you a method that still uses the loop. I'll show you that in a moment. I'm going to show you another solution that allows you to still have a real-time callback and doesn't require a loop. So for now, I'm just going to comment this loop out, but we'll come back to that in a moment. So the other solution, we're going to need a variable to track our current articulation like we had before for our previous script. So I'll call it C, and we'll set it to 0. What we're going to do is we're going to assume that there is only ever one of these muters active at a time, and that is the current articulation, C. Okay? So it's very important that we assume that only one is active at a time, not two, just one. That means we don't have to loop through and disable all of them. We only have to disable the one that is currently active. So what we do is we go muters, and then put C in there because that's the one that's currently active. Set attribute muters C dot ignore button and then 1. So now we're only ever bypassing the one that is currently active. And then what we do is we activate the one that was pressed, which may also be the previous one that was pressed. It doesn't matter. So what we have to do, we have to now set our C variable to the one that was pressed. So we get the index of the key switch, and that also gives us the index of the muter, same as we did down here. And now that C has been updated, we can paste this same code, but change that 1 to a 0, press F5. And now if I press C#0, it's going to change to the staccato articulation and mute the sustains. And now we can switch back. And this will work for any number of articulations as long as the key switches are set up in this KS array. Now remember, I said it's important that we assume that only one of these is active at a time. So if I have both of them active, and now I'm pressing the staccato button, I'm pressing the one to switch to staccato, and it's not changing anything because by default sustain is the active articulation. If I press sustain, then it works. But we have to assume that only one is active at a time, so we have to manually make sure, just for the very first time, that the correct articulation is active. Okay, getting back to this loop thing. So I'm going to delete, actually I won't delete it, I'll just comment that out for now, and uncomment our loop code. So getting back to the loop method. So this is clogging up the real-time thread, and that's not good. So what we can do is we can say, instead of running the onNote callback in the real-time thread, all we're doing in here is stuff that isn't real-time, so don't worry about having it in the real-time thread. So the way we do that, the way we say that we don't want these threads to be real-time anymore because we're not using them for real-time stuff, is we tell HISE to defer the callbacks. And we write synth.defer callbacks and put true. And I'll hit F5. And does that work? Ah, there we go. And you can see a D appears next to each of these callbacks. So you'll notice it's not next to the onInit or the onControl callback because those aren't real-time callbacks anyway. They just work in the what's called the message thread. But these real-time callbacks, the ones that work usually on the real-time thread, these are now deferred to the message thread, so we can do loops and things in there and it won't slow the program down. However, if you have things that are critical, maybe you've got real-time critical articulation switching, then you wouldn't want to do this because you'd want to keep those on the real-time thread. But this is just a way, if you are wanting to use this loop method, or loops in general within real-time callbacks, it's best to defer those callbacks if you can, so that you're not going to cause any artifacts or other audio dropouts. Another way I can think to organize samples is to use different sample maps. So let's add a sampler, and I'm not going to do any scripting for this, I'm just going to show you. So when I saved my sample maps earlier, I actually saved two sample maps, one for the Velocitybased and one for the when we had all the articulations mapped. So you could actually have the articulation switching based on changing sample maps. Now this isn't something you'd want to do in real time, but you might have it set up as an on-screen button that's clicked, or perhaps it's a separate preset, so the user could have several instances of your plugin loaded with each one having a different articulation. So I'd still say this is a valid method for separating out your articulations, but I wouldn't use it for real-time switching. So we've looked at pretty much all the ways I can think of to organize the samples. There are sort of variations on this, and of course you can combine these methods and make sort of hybrid methods, but this is the basics of it. So now let's look at some more ways that we can actually switch articulation. So we've looked at key switching. Let's now look at using a continuous controller to switch articulation, and this works with any of these methods. So it doesn't matter which one we're using. It doesn't matter if it's sampler based and we're using different MIDI muters. It doesn't matter if it's spread across the range of the keyboard. It's going to work with all of these methods. So we're just going to stick with the group based one just to make this easier to see. So I'm going to delete all these other samplers just so we've got less clutter. Okay, so I'll re-enable this sampler and I'll re-enable our script. I'm going to have to make an update to this sampler because I changed the name of it to group based, whereas before it's called sampler 1, and I don't want to change the script, so I'm just going to rename the sampler back to sampler 1. Okay, so there are a few different methods we can actually use to change our articulation. So we're using our key switches so far, but we could also do this with MIDI CC, and this is a common method, especially if you're using what's now referred to as the UACC, Universal Articulation Continuous Controller, which is basically using CC32 to change articulation, and there's a standard now for this, which has been adopted by a few developers. I use it as well. It's a very it's very much geared towards orchestral libraries, but you can adapt it for your own purposes. It's a very flexible standard. So let's imagine we're using the UACC. We're using CC32. So we'll have another array which is going to store our UACC values. So we're using CC32 and we're going to use the different values to trigger different articulations. And there are two advantages to this over key switches. The first is with key switches you're limited to the range of the keyboard that is outside of the playable range of the instrument, so that might not be very many keys. The second thing is key switches aren't tracked by a lot of DAWs, so if you have a key switch at the start of your piece of music but you actually start playback in the middle, it's not going to track that previous key switch, but with a continuous controller the value will be tracked, and also with a continuous controller we have 128 values. So let's decide which values we're going to use for our articulation switching. We'll have 1 for our sustains, we'll have 40 for our staccatos, and we'll have 50 for our flutter. I don't know if those are actually correct for the UACC standard, you can check that out, but for our demonstration that will do just fine. And let's have another constant, and I'm just going to call it CC. Now usually you'd have this, like I say, CC32, but because I don't have a hardware controller linked up to CC32, I'm going to use my mod wheel, so I'm just going to set this to 1. And now this will work alongside our key switches, by the way, so it's not one or the other. We can have key switches and UACC. So we're going to go to the onController callback. We're going to use my favourite function, indexOf, to find out if the controller value is triggering an articulation change. And then we're going to change the articulation. So the first thing to do is we want to find out which controller has caused the onController callback to trigger. So we go message.get controller number, and if it's equal to our CC constant, so in this case it'll be mod wheel because I've set it to 1, then we want to check if it's got the right value for one of our articulations. So we're going to go uacc.indexOf message.get controller value, and then does not equal -1. So exactly the same as we were doing for key switches. So it's pretty much that same function, but instead of getting the note number, we're getting the controller value. And then we want to set the active group. So we're going to go sampler1.set active group, and the group index is going to be this, +1, same as before. I'll hit F5 on that. Okay, now the only problem with me demonstrating this with the mod wheel is my mod wheel isn't that accurate. It's a bit temperamental. So I'm going to output the CC values to the console so we can just see what's happening. And we'll do that. Let's just do that here. Console.print message.get controller value. And if I move my mod wheel, we'll see some stuff down here. There we go. So now we can see the value of my mod wheel. And if I open this one again, we can track the group number down here just like we were doing for key switches. So now as I move the mod wheel, so I'm going to move the mod wheel to, I'll try and get it around 40, and we should see that change to 2 when I get to 40. You see that my mod wheel won't settle on 40, it's 38 or 43. So let's change this number to 38 and hopefully I'll be able to catch it. There we go, 38. And did the group change? There we go. But I've got to play a note first, but then the group changes. The reason I've got to play a note first is because this display group thing is updated in the onNote callback, not in the onController callback. So now if we try and get the mod wheel to around about 50, 54 or 48, okay, we'll have 48. We should get the flutter articulation. And now I can get the mod wheel to 1. That one worked. We'll now have sustain. And the key switches still work as well. So we have a nice combination of both methods, which will suit different users depending on what their preference is. So, for example, the CC is useless, in my opinion, for real-time performance. You won't want to use that for live performance because it's so hard to get those exact values. But it's great in a sequencer because of the tracking, whereas key switches are really handy in a live performance. So, I think it's good to have both methods. Now, in addition to using the UACC, you really should use program changes because that's kind of what they were designed for. And there are certain scripts, I know there's one for Reaper that works well with program changes, and they're also tracked like the UACC is. And HISE is a great way of handling program changes. So I'm going to do, let's see how to do this. Okay, we'll have another array, we'll call it programs. And we're going to use the same UACC values, and I actually do this in my own projects, and the reason I use the same UACC values as I do for programs is it means if a user is using the UACC and then they decide to use programs, or they're using a mix of them, they don't have to figure out a new set of numbers. It's like, okay, programs and UACC are interchangeable in terms of the actual values. So let's go back to our controller callback. So we could actually kind of combine programs and UACC into one big if statement, but we'll do it as two separate ones just for the sake of clarity. So we'll say if, now let me see what it is, but we've got to check, whereas here we were checking if the CC was CC1, if the mod wheel had triggered the callback. Here I want to check if it's a program change message, and I'm just checking what it is. So that's what it is program change. So I'm going to say if message.isProgramChange, and then we're going to do pretty much the same thing we did here. Oh, I'm going to delete that console output now. We don't need that. Yeah, pretty much the same as we've done here for this if statement. So I'm just going to copy that. But instead of UACC, we're going to refer to our programs array. So we'll put programs. And instead of controller value, we're going to use this one, get program change number. and then we can set the sampler set active group to the same as this. Add 1 to it. And now that is all set up for, no it isn't, what's that? Call a program change outside of MIDI event callback. Is program change. Ah, okay. So that is because, right. I've got 2 curly braces here, so it thinks I'm ending the onController function. So that shouldn't be there. That should be there. Okay. There we go. So now it will change the articulation with either a UACC, a key switch, or a program change message. I can't demonstrate the program change message because my keyboard maybe does output programs. Let's see. Oh, hang on, my keyboard does output program changes. Okay, let's see if we can work this out. Program change. Ah, brilliant. Okay, let's track this. So we'll have a look at the program change value. I've never actually done this before. Print. So let's see what program change values my keyboard outputs. That's interesting. Okay, I think we found a bug here. This is interesting. So I'm changing through the program change numbers. Usually I test program changes in a DAW because I didn't realize my keyboard actually outputted program change numbers. And but what I'm doing, all I'm doing is I'm pressing a button to change the program number, and you can see it's giving me this error message, line 3, get controller number outside of onController callback, and this is line 3, and that's clearly within the onController callback. And somebody reported an error like this recently on the HISE forum, so I'm guessing I've found a way to trigger that error. I think I know what's happening. I think because it's receiving a program change message, when I'm saying get controller number, it's saying I can't do that, it's a program change. We can test for that. What we'll do is we'll put this if statement above, and we'll put an else. We'll make that an else if instead. And now I'm going to hit F5, and if I change program, I'm assuming I won't get this error message now. Yeah. So we changed to program 1, and that's going to be our sustain articulation. And now if I change to program 40, I'm going to have to press this button a lot, we should get the staccatos. Okay, so now we're on program 40. And now if we go to program 50, so the program change messages work really nicely. That's great that I can test that. I wish I'd known about that before. One thing I've noticed is my program change on my keyboard is saying 51, where in HISE it's saying 50, so I don't know if my keyboard is 1 based and HISE is 0 based. I think that's the issue there. But yeah, so that's the program change method of changing, and that is a method you really should employ if you can, if you're using the UACC as well, because that's like a really old MIDI standard, the program change. So we're pretty much coming to the end of this now. We've organized the samples and looked at different ways to switch between the different articulations. There are other ways to switch articulations. One way I particularly like is to use crossfades. This is especially good for tremolos or flutter tonguing and sustain. So let's have a quick look at that. So I'm going to add, let's just mute these for now, just bypass those. We'll add a sampler. And the way I'd usually do this is to use 2 different samplers, but you could do it in one sampler if you don't have multiple dynamics. And in this case, we don't have multiple dynamics, so I think that's exactly what we'll do. But if you're using multiple dynamics, then you're going to use 2 samplers, and you're going to use gain envelopes to do the crossfading. Or you can script it if you're feeling like a challenge. So let's just map some sustain samples in here. So I'll map the sustains to group 1, map the flutter tongue to group 2. So we'll just move those flutter tongue samples to group 2. And oh, actually, we've only got one group, so we need to add another group. So let's do that. We're going to have 2 groups. There we go. And now we can map these to group 2. And the sustain samples have a higher key range. They go up to key 91. So let's just make sure the flutters have the same range. So we'll just stretch the top sample there. Okay, so now the flutters and the sustains cover the same range, but we're going to use them as if we're going to crossfade the group. So we're going to enable this setting here, group XF, and this is usually used for dynamics, and that's usually what I'd use it for. And we can set the crossfades, we can have up to 8 groups, but we can set the crossfades in this table here. So if we go to group 1, which is the sustains, we can do something like that, and we can make it kind of equal power if we want. And group 2, that'll be fine like that. And now we need to select group X fade up here and add a modulator. So I'm going to add my mod wheel. So MIDI controller, we'll turn the smoothing right up on this. And we'll even affect this table a bit as well. Okay, so now we can see where my mod wheel is by this line that's going back and forth and this up here. And if I play a note, it's going to be sustain. And if I hold that note and move the mod wheel, it's going to fade into the flutter. And if I push the mod wheel right to the top and play, it's just going to be flutter. Now, this is a really fun way to switch articulation, especially if you're performing live or using a breath controller or something like that. There are 2 things to be aware of. The first is you need to have your samples looped, especially with something like flutter, because they're generally shorter samples than your sustains are going to be. So you need to have them looped because you don't want to be crossfading into silence. The second issue with this is it's going to increase your voice count. So I'm going to play a note, and hopefully you can see the voice counter up at the top there. I'm going to press down a key, and I've got the mod wheel all the way down. So we're just going to hear sustain. But it's using 2 voices. And now, not such a big problem with this, but if you've got 3 dynamics and 3 mic positions, that's going to be like, what's that, 3 times 3 times 2, so you're going to have 18 voices playing for 1 note. So that's not so great. The technique I've come up with in my libraries for this is I don't allow the second voice, I don't allow the flutter tongue to trigger until the controller, the mod wheel, is at least a value of 5. So that way, having it right down at the bottom there, you're only playing the sustain. So that's the solution I've come up with, but if you come up with a better one, let me know. So the only thing we haven't covered today is how to change articulations using controls on the interface. But I don't think that's something you guys need me to cover after what we've gone through so far. I think you should be able to work that out. But if you do want me to do that, let me know, and I'll put a little extra video out. But basically, it's the same procedure we've already had, just instead of key switches, you're going to use an array of buttons. So you'll have like 3 buttons instead of the 3 key switches. And then it's back to our old friend, index of, and then you set the active group or enable the sampler or change the velocity or whatever it is, depending on how you've mapped the samples. So this has been quite a long video, I'm guessing. I mean, I'll find out when I edit it, but hopefully we've covered a lot of ground. And you've got what you need to start implementing multiple articulations in your instruments. So if you have any questions, comments, suggestions, leave them below the video on YouTube or below the video on Patreon if you're watching it over there. If you haven't subscribed to my Patreon and you would like to become a patron, there is a link in the video description on YouTube. So it only costs $1, and with that you'll get early access to all of these longer tutorial videos, these monthly videos that I do. If you go for the higher tiers, you'll get some extra content pretty much every week. I post little videos, snippets, just bits and pieces about what I'm up to, what I'm doing, and sort of sneak peeks at projects I'm working on. So check it out, and please join the community over there if you would like to. As always, thank you for watching, and I'll see you next time.